Thank you for attending, guys. My name is Young, and today we have a webinar on using Terraform to deploy a secure Kubernetes infrastructure as code. Our host and presenter will be Glen Vice President of Product Management at NeuVector, and accompanying him with demos and presentation will be Alejandro Chacon, Support Engineer at NeuVector. Glen, would you like to take it from here?
All right. Thank you, Young, and thank you everyone for joining us today for this exciting topic. There's been a lot of articles and coverage of this topic of infrastructure as code, so we're happy to explore that in this intro webinar. And as Young mentioned, today I'm going to be joined by Alejandro. And for his day job, Alejandro supports our customers. But one of his passions is to experiment with a lot of these new cloud native tools. And so he's been playing around with Terraform and using it to deploy infrastructure and NeuVector. So he's going to be doing some demos for me today. And he joins us from wonderful Uruguay in South America.
Thank you, Glenn.
All right. So why don't we just jump right in and get started? All right. So as you all know, containers and Kubernetes, microservices, all very exciting topics. And the big reasons that people are moving to containerized and cloud native infrastructures are, to get several business benefits. And those include being able to have huge deployments, the more and faster software releases. In fact, I just read an article this week about Airbnb deploying 125,000 updates every year. So you can imagine how many a day that translates to be. And so everything really has to be automated and fast in order to support that velocity. And the other big benefit of moving to a cloud native infrastructure is the ability to better match the infrastructure you're using with the demands of your business, and therefore, in some cases, be able to reduce the cost of the infrastructure. Now, the need to deploy faster and move quickly really drives the need for automation. And that is what is driving the need for what we call infrastructure as code. So let's take a look at, first of all, what is infrastructure as code? Well, at a high level, it really enables us or you to express the cloud resources that you want as code. And so you're able to declare the desired state of the infrastructure that you want to deploy and configure. And if you need to update that, if you need to add resources, it makes it very easy to update that state. You simply change your declarations, apply that in a typical cloud native fashion, and boom, your resources can be updated. Now, let's take a look at some of these terms, especially the term code, right? We're talking about infrastructure as code. What is code? Well, we're not talking about Java code or Go code. In today's webinar, we're going to be talking about a specific type of code called HCL, and that is from HashiCorp, and that's used with Terraform, and that stands for HashiCorp Configuration Language. But code can also be referring to JSON as well as YAML files. So that's how we kind of have co-opted the term code. And what's the difference between like scripts and code? In the old days, Linux admins, when they deployed a new server, would write a bunch of scripts, and that would then determine how that server came up and certain configurations and maybe even applications were installed. So we're not talking about scripts here because scripts is not really code. Scripts were very either OS or platform dependent. They had a lot of little nitty details that if you got one wrong could present some problems. And most importantly, scripts were not managed as code in a software development lifecycle like code is typically done. So, we're implying that when we use the term code, that we are managing it just like code. There's a life cycle of this code, which is to create it, to test it, to check it in. If it needs to be updated, it needs to be checked out. And then updated, retested, and then reapplied. And scripts were never really used in that way before. Now, why can we deploy infrastructure as code and using code today? Why couldn't we do it 10 years ago or 20 years ago? Well, some of the main reasons why are that we have these great public cloud resources that are now available, whether it's AWS or Google, IBM, Microsoft Azure. You're easily able to declare your infrastructure that you need, and they've abstracted all of the little nitty details of bringing up that infrastructure and all the things required for that, and just expose some of the key parameters that you need to deploy that infrastructure, such as how many nodes or what's the VPC configuration. And so therefore, you can easily describe that infrastructure that you want to have created. And so that's really what's been driving this infrastructure as code. Now, what are the benefits of using an infrastructure as code approach? Well, clearly, speed. Right? If we need to deploy something quickly and we've got the code for it and the public cloud resources provide support for it, we can just hit an apply button and voila, we've got a bunch of resources that we need. A second key benefit of it is consistency. Going back to the Linux admin scenario, there's a bunch of scripts that were written, and Joe went on vacation, and Mary came in and tried to read those scripts and edit those and deployed new infrastructure, and it was all different. So when we deploy infrastructure as code, we get consistent deployment. So the certain configurations that we want and the type of infrastructure we want can be consistently deployed. Scalability, when we need to increase the amount of resources that we need, we can easily ramp that up just by annotating or editing our declaration in our code and then applying that, and then the public cloud service provider will do its magic in scaling up, adding nodes or network or resources or other resources. And a couple other benefits are cost. I mentioned cost, which is if you can very quickly and consistently and in a scalable fashion deploy your infrastructure, then you can better match what your business needs with the actual infrastructure that you have running and that you pay for. So therefore, you have better cost management. And finally, and most importantly, which is the topic of today's webinar, is how can we securely deploy our infrastructure as code? Not just deploy any old infrastructure, but make sure that it's secure when it's deployed and it stays secure as we move forward. So on to Terraform from HashiCorp. As I mentioned, Terraform uses a language called HCL. And the real value of that is it puts these declarations in an easily read and modified, it's human readable formats for how many nodes I want and what my VPC configurations are and what my security groups are. And then what other applications do I want to be deployed? It is compatible or supports JSON, but JSON is not quite as easily digestible by the average human. So that's why HCL has become so popular. And you can see a link there to a description of HCL down there from HashiCorp. Now, the Terraform supports many modules and providers. So a little bit of terminology here. There are many providers, which typically are companies like AWS, et cetera, Google, and they have provided a bunch of resources made available and described or integrated with Terraform. And modules are in HCL, and they're really compilations of, you can think of preset configurations. So modules could incorporate 3 or 4 resources from the Google Cloud that you're bringing up, as well as other providers' resources that you want to add to it that are specific to the infrastructure that you want to deploy. There are hundreds of providers available on Terraform, and I think over 9,000 modules available that you can choose from. And then obviously you can customize those for your specific needs. And once you've installed Terraform, it's very easy to then deploy your infrastructure with simple commands. Init really grabs all those modules and plugins and incorporates them into your deployment. Plan enables you to review what Terraform is going to do, all of the actions and all of the resources that are going to be created. Apply, just like kubectl apply, is going to then create those resources, and then destroy can easily remove that. So if you only need some resources for a short amount of time, you can easily go through this process and remove them and not have to pay for them. So why don't we start with a very simple example of deploying some public cloud resources just to get started and to get familiar with Terraform. Alejandro, do you want to show us a quick demo of that? And it looks like you're muted, Alejandro. You're going to have, yep.
Okay,
there you go.
Thank you, Glenn. Let me share my screen. Okay, now share. Could you see my screen, Glenn?
Yep. And I didn't mention the link there at the top is where all of these examples currently exist. And we're going to be moving these over to the NeuVector GitHub page soon. But for now, if you want to look at any of these, you can go to this link.
Okay, thank you, Glenn. Awesome. Hi, everyone. My name is Alejandro. I am going to show you a couple of examples using Terraform in our case. In this first demo, we are going to deploy a simple GKE cluster using this simple repository. For now, we are going to follow this basic step. We are going to authenticate using our Google GCP account, and we are going to clone this repo in our demo to get all the information for this infrastructure that we are going to deploy. Okay. For now, we are going to open the terminal here to clone our code. Inside our code, we have a specific sampler for some resource that we are going to deploy. In our case, we are going to deploy one cluster and one specific VPC for this example. And we are going to use modules, Terraform modules for this example. And here we are going to put our cluster name for this example. We are going to call webinar. This example, okay. I am already logging in my GCP experimental account. I'm going to go into GKE cluster module example to go to see our configuration deployment. In this case, we are going to use module to call our GKE cluster, locating our GitHub account with all the files configuration using our specific provider, Google with the specific versions and Terraform, and configured with a specific variable bars or Terraform bars for this deployment. Okay. To initially say our deployment, we are going to use a Terraform 14 version. In all our demos, we are going to use the same command. In this case, I am using some specific alias to differentiate between the Terraform 13, 14, and 15. For now, we are going to initially say our plugins and providers that we are going to use in this specific deployment. Okay, this is successfully initially saved. And we are going to run a simple command using apply. Inside the apply, we do first the plan and then apply. We also could validate our syntax or configuration using in our deployment, but we are going to follow this deployment. Okay, this is right now is deploying the cluster, Glen.
Yeah, so this will take a minute or two. So while it's creating that, we can talk about a few things we're seeing here. So the first thing you showed when we did the apply, it'll summarize all the actions it's going to take, and you put yes. And then, yeah, this is the example that you're using now. You got that from the Google provider or the Google modules list, right, on Terraform, in the Terraform registry. I guess there's many different modules we could have selected from, and there's many configurations, right, Alejandro?
Yes, here in our registry from Terraform, we could choose from our cloud provider specifically. In our case, we choose Google Cloud Platform to deploy our test cluster. And inside our provider, GCP, we are using right now this specific module for the GKE, and we use for the demo purpose a basic cluster configuration. But here we could choose a lot of different configuration from the basic to the more secure cluster.
Yeah.
Put zonal, regionals, private VPC, private networking, and private zonal.
Right.
And we have a lot of options here.
So we're doing a fairly simple deployment, but there are many options. And because we're talking about security today, you know, there are many more secure clusters that could be deployed. So what if we did want to deploy a more secure cluster?
Yes,
I think you have an example, right? That deploys a cluster.
Yes, we test using a specific private with private with networking in our case. But in this case, we deploy using a private GKE cluster with a Bastion host. In this specific Bastion host, we configure a specific proxy to reach our master configuration or our cluster configuration using SSH tunnel. In this case, we could see in this step 9 that we need to reach our cluster, to our secure cluster, we need to configure some specific alias using some specific proxy. And before we need to apply our using GCP also, the connection between our Bastion host and our cluster configuration inside the same VPC. Okay, we could configure this same example using BPM also to get a specific private cluster in our case. This is another example.
Yeah, so this is a little bit more complex example, but it's going to be a more secure deployment where you're not going to expose the cluster externally. You've got to VPN in or SSH in order to access the cluster through a Bastion host, right? Okay, so let's check back on your deployment and see how it's still going. You could see that it took a little bit to create the VPC and the subnets. That took a while. And now it's creating the instances, I believe. Oh, there we go. So you can see that it took a few minutes to deploy the cluster. How many nodes did you deploy there?
3 nodes. 3 nodes. Let me get the credentials. In our case, we are using the webinar name. Let me introduce our zone. Use central 1C, and our project ID is just to get the context to get to reach our cluster. Project NB demo. Okay, in this case, we are fetching some context information, and we could get nodes to configure our cluster installation. Okay, here we are. 3 nodes using the default installation for
up for 75 seconds. Yeah, looks good.
Yeah, this is a simple example.
Yeah.
Okay, Glenn, let me.
And I think we're not going to do it today, but the private cluster you showed the example of would take much longer to deploy, right?
Yes, take a long maybe
10 minutes.
10 minutes to deploy the cluster.
All right. Okay. Good. Thank you, Alejandro.
Thank you, Glenn. Thank you, guys.
Yep. So let me go back to my overview here, and we already got a question here. You know, there's thousands of modules available. How do we pick, and how do you choose whether you pick a pre-existing module or create your own module? Yeah, I mean that can be tough, you know. And you imagine now there's 9,000 modules, but imagine there's 20 or 50,000 modules. How are you going to find one? I suppose, you know, just like you find the best open source software. Things that are popular, things that are used the most, communities that identify which ones are going to provide your needs. And if it doesn't quite fit what you need, you can either extend it or, of course, create your own module. All right, so moving on. Now, we already started to talk about secure infrastructure as code because we talked about it deploying a simple GKE cluster, but, you know, then, or set of nodes, I should say. It's not even a cluster yet. And then we also talked about, well, if we wanted to make it more secure, we could create a private network for it. But there are many other things that should be considered keeping a secure infrastructure in mind, and those are configuring the appropriate role-based access controls, especially on any Kubernetes access. You know, you probably heard of the Tesla hack where they left the Kubernetes console open with no password and resulted in some crypto mining software being installed. So configuring role-based access controls and passwords is important. Firewall rules. I don't know if you saw in the Google module list, you know, you can configure firewall rules, or in AWS security groups. SC Linux as well can also be installed and configured. And another major thing that can be done is to deploy a security solution layer on top of your infrastructure. So if you're deploying a Kubernetes or container infrastructure, a solution like NeuVector, which provides a security layer on top of that, can also be critical. And what that's going to enable you to do is to continuously audit all of the configurations that have been done on the Kubernetes cluster and the infrastructure, as well as ongoing visibility and protection of any workloads that you're going to run on that infrastructure during runtime. So before we get into how do we automate the deployment of a solution like NeuVector, let's talk a little bit about, for those of you who are not familiar with NeuVector, what it is. So it is a full lifecycle container security platform. So full vulnerability and compliance scanning and management. Everything from when you start to build your images can trigger a vulnerability and compliance scan, also monitor the registries, and then in the production environment, run your CIS benchmarks. And that'll be critical for the Kubernetes and Docker CIS benchmarks to make sure that all of the recommended security configurations on your cluster are in place, as well as making sure that those don't change or inadvertently be edited over time. And then when anything starts to run in the infrastructure, whether you auto scale up a node or a new container starts to run, immediately being able to run to vulnerability scan those and compliance scan those running resources is also critical. And then once everything starts to run, it's critical to be able to protect any applications that are going to start running on that infrastructure. So for that, NeuVector provides a container firewall and container workload security. And again, it's cloud native, so you essentially declare what your application is allowed to do. You know, what kind of behavior is your application allowed? And that is what kind of network connections it's going to be allowed to make and what kind of process and file activity that container can perform. And once that's declared, that can then protect the workload once it's in production. Now, just like HCL, Kubernetes provides a YAML-based way to define those as code in what's called custom resource definitions, or CRDs. And so what you're able to do is to declare your security policy as code, you're able to test it, and you're able to push it into your runtime environment to protect those workloads, all in an automated fashion. So with that as a quick backdrop of a security solution, let's take a look at how we can use Terraform to make sure that a solution like NeuVector is deployed. Now, when you deploy NeuVector, you're going to deploy a number of different containers, and then you're also going to have to expose the access to that typically through a console, but could be through a REST API. So we're going to deploy some controllers, managers, enforcers on various nodes. And Alejandro, do you want to show us a demo of how you can deploy NeuVector using Terraform? And I think you're going to use Helm as well, right?
Yes, Glenn, thank you. In this case, we are going to use a Helm deployment, but parsing to Terraform files. And in this example, we are going to use as provider our Terraform Helm provider, and inside our Kubernetes Helm provider also. In this case, we build this module just to install or to follow the NeuVector installation using Helm. It's just to replicate the steps in our GitHub page using Terraform. For now, this is our inputs variable for our module. If we could specify the tag version for our NeuVector deployment. Also, we could use these kind of variables to customize our deployment and pass in the deployment time our registry username and password that we have permit to download the NeuVector image. In this case, we are going to use this portion of code just to configure using module and NeuVector deployment. Let me go to the Visual Studio Code to see our second demo. In this case, we have here our module configuration, setting up for one specific version, using 3 scanner replica for our security scan, and 3 controllers for our demo purpose, we are going to expose using load balancer. Here we are going to pass our Docker username and password using a specific and sensitive variable in Terraform. Let me go to this folder, and then if we follow the steps, we need to pass the specific context that we are going to deploy our configuration. For now, we have we have inside the GKE cluster. We are going to copy the context and put inside our export variables. Okay, and pass this variable to in our deployment. Take this configuration. Okay, we are going to initially say our NeuVector deployment using Helm with these specific variables. Okay, here we are going to download the plugins. And for now, we are going to apply this change to deploy NeuVector in our cluster that we created before. Okay, here is going to create let me open a new window to see in our cluster the configuration. We are going to change from the NeuVector namespace. This is the namespace that we are going to create for this demo.
It looks like we're creating the namespace, we're creating the Kubernetes secret, and then we're going to create the pods.
Okay, here we are. It's creating the NeuVector installation.
Yep, and you could see it's pulling the containers or images. Controllers are really the control plane for NeuVector. The enforcer is the daemon set that gets deployed on every node to be protected. The worker node does all the packet filtering and security on that node. The manager is what we're going to log into to expose that. And the scanner is a scalable scanner. We have 3 scanners running for scalability, but you can scale that up or down if you have thousands of images to be scanned.
Okay, the deployment is done. Let me get the load balancer or external IP address and share with you, Glen, for the demonstration.
All right, so Alejandro's grabbing the publicly accessible IP address for the console that's been created with the load balancer.
Great, I'll pass you in the chat.
Okay, and he's sent that over to me.
Okay,
so I will share my screen.
Thank you, Len.
All right, let's take a look here. I'm gonna log in, see what we got. All right, so we're gonna log into the NeuVector console. The default is admin. And you can see this is a new deployment. The next thing we would do here is we'd apply the license, and then we'd be able to monitor and manage our infrastructure. Now, this is a new cluster and a new deployment, so we haven't deployed our applications yet. So I'll just switch over to this already populated console here, which is a demo console already running. And just to give you a feel for what NeuVector will provide once it's up and running, you could see a network map of all the containers that are running, all of the network connections being made. The ones in blue lines have been allowed, and the ones in red lines are either segmentation violations or network threats that are being detected. And you can easily filter by a set of namespace containers, etc. You can also see when we do vulnerability scanning, what vulnerabilities exist on any container, as well as compliance violations. Same could be true of images that are scanned. So that's just a real quick look at NeuVector. So let's flip back now to our flow here. So we deployed a simple example. This one integrated the Helm chart of NeuVector into that deployment. But a more secure deployment would be, number one, deploy your infrastructure and your Kubernetes cluster. Number two, deploy NeuVector like we just did. But in addition to that, let's try to configure everything as much as possible in that initial deployment. So the license that needs to be applied, let's apply that. Let's also do some initial configuration using config map so that we don't have to go in and log in and do a bunch of configurations manually. And in addition to that, whenever you deploy infrastructure automatically, you might also want to deploy an application stack that goes with it. That could be a business app that is going to be part of your automated deployment, or it could be other monitoring or other resources that you want to make sure is available on every deployment that you do. So why don't we also deploy an application stack, but let's make sure that any application like that we deploy is already protected by security rules. In other words, the allowed behavior that we talked about that is expressed as a CRD, which declares what type of network behavior it's allowed, what type of process and file activity is allowed. Let's make sure that that's also deployed so that when that application starts to run, it's already secured. So Alejandro, why don't we flip over to you and do a more complex deployment.
Okay, Glenn, thank you. Let me share my screen right now. Okay, for now, we are going to use this repo using the NeuVector deployment, but in this case, it's more complex example because here we're going to apply the license key in the build time when the configuration is spin up. And also we are going to enable the config map configuration and change the admin password and add a new reader. In this case, we are going to pass the reader password in this configuration. We need to have as a prerequisite here the license key in your local machine and your local folder because we are going to get the specific path and load the license key configuration. We are going to copy this all configuration for this module to the NeuVector installation and passed in our playground. In this case, we did a couple of changes here. We passed the registered username and password and our admin password as a sensitive variable in this installation, and also configure a demo or reader user in our installation, passing the password inside our configuration.
Mm-hmm. So you're saying the admin password, you're changing that so it's sensitive, so therefore we're not going to show it here, but for the read-only user you're going to create, then we're just going to pass it in the clear here, right?
Yes, in this case, we have the license key loaded in our root folder.
Yep.
We're going to apply the change to install this NeuVector installation in another cluster. In this case, we are using our labs in AKS, Glen, It's just
Okay, we're deploying on a different cluster this time, AKS cluster.
Yes, we changed from the context right now because all context was in GKE, and right now we are going to deploy in AKS.
And I think you mentioned in this one, we're not using the Helm module. We're using more basic, the kind of kubectl commands to deploy, and then also deploying some test applications.
Yes, the difference between this deployment is to get more customized example. In this case, we parse all the NeuVector configuration in Terraform files, and we need to apply all this configuration parsing this using the Kubernetes provider. In this case, in the last example, we use the help provider. In this example, we are using a Kubernetes provider to deploy the NeuVector.
Yeah, good point.
This is why we have a lot of resource deployed in this example. 33. Right now, we are waiting for the controller stay up and running. Let me confirm in another window. Just to NeuVector, namespace. Also get the bots installation. Right now we have all running. We're waiting the signal. Let me share with you, Glen, the external IP address for this example. Okay, here. Okay. Meanwhile, the configuration.
So what's it doing now? Is it deploying the demo pods, the application stack that we talked about?
No, it's waiting to the okay, let me change to the demo. The demo namespace and get the test pod. Okay, are running. Okay.
So this is our demo application stack with Nginx, Node, and Redis pods running.
Yes, let me stop and share and pause them.
Okay, so it looks like everything is deployed. Why don't we log in and take a look at what we see here? So that is the public IP that you created. Let's log in. Now, the first thing I'm going to try here is just to log in with the default password. And you can see that doesn't work because Alejandro has changed the default admin password in the deployment. And you can see this is an initial deployment, and you could see the license has already been applied as part of the deployment. So when everything comes up, NeuVector is up and running, and certain configurations have been made, just some simple ones in this example, but of course more complex ones can be done. So in this case, the admin user password was changed and a read-only user was created as well. So you can not only create users and assign them, but do any of the configurations that are possible as part of the config map. And that is whether it's setting up a webhook for alerting, proxies, SIM servers with syslog, all of the configurations can be done. And then once we are deployed, we can see here that NeuVector has, that we have deployed these demo application stacks here, and that we see some network connections in there, and we could see those connections as they occur. Now, if we look at the policy, we can also go into the groups, and we see something interesting here, which is some of these have something called a CRD applied to them. So if I look at my Node.js deployment, I can see there are 2 pods here in the deployment. I can see that there are network rules and also process rules that exist for this application. And unlike in a standard deployment, I can't go in here and change any of these rules. And the reason is that these were declared and applied using the CRD, using the YAML file. And so if you want to change any of these process rules that this application is allowed to perform, or any of the network connections that it's allowed to do, you're going to have to actually check out that CRD, edit it, go through your test process, and then deploy it again. And so this is an example. This is the CRD that was applied as part of the deployment. Now, the typical workflow for automation and pipeline, integrating it into the pipeline, is that you would have a staging or a test environment. You'd have your cluster up and running. You'd have NeuVector running, and then you deploy your application stack. In this case, Nginx, Node, and Redis. And you would run your application traffic through there. NeuVector can then use its behavioral learning to learn all of the behavior and create for you all of these rules, these network rules and the process rules. You could then review these rules. For example, you could see here that this Node.js pod is allowed to access this API service using SSL. So this is an egress control rule. And so you can edit these rules to customize them and again, test them before they're checked into your production security as code repo. So once this is locked down, this gets checked into your repo, and it represents the security as code for this application stack. And it can be applied to any production environment like we just saw here. And if you look at this, this is a typical kind of YAML file format, but it's in a custom resource definition of a NeuVector security rule. And it expresses in this YAML file all of the rules that you see here in the console, all the process, file, and network rules. So you can see there's a DNS lookup allowed for the Nginx pod. You can see that an HTTP connection is allowed to the Node.js in the demo namespace. You can also see that there's certain processes allowed to run in the Node.js pod as well, or Nginx pod, sorry, we're looking at the Nginx pod. You can also see here that when this CRD is deployed, we should be in what's called a monitor mode. So before the applications actually start to run, we're going to make sure that they're either in a monitor or protect mode. And so by monitor mode, we mean that we're going to just notify if there's any violation of the network rules or process rules. In a protect mode, if the CRD was set to protect, then that unauthorized behavior would be blocked. And so the idea is that you should be declaring your security rules. You should be checking in as code those security rules, applying updates just like you do any other updates to your Kubernetes resources. And you should deploy them before you deploy your application or you update your application. And so that is going to ensure that number one, your applications are secured once they're deployed, and number two, that you can automate this whole process so that you don't have to manually go into a console or issue CLI or REST API calls every time you want to update or deploy an application. You can just build this into your pipeline. All right, so that's a quick tour of some of the capabilities of how to deploy secure infrastructure and a security solution on top of that. Now, really, as you can imagine, there's endless possibilities for automating your deployment of infrastructure and securing it. You can start early in the pipeline by deploying your build pipeline and scanning images in the pipeline and rejecting them. You can update your resources, whether it's your Kubernetes resources or your GKE or Azure resources, or whether it's NeuVector, whether you want to update a NeuVector version or any configurations can be handled through your infrastructure as code deployments. So, that's all we had for today. I hope you enjoyed this intro to secure infrastructure as code. Let us know if you have any questions, either in the question and answer box or in the chat. If you don't have questions, let us know what types of resources you would like to configure as part of your configuring a secure infrastructure. So thank you, Alejandro, for doing those demos. And let's take a look at some of the Q&A. We're getting a lot of questions, which we can start going through now. Okay, how does NeuVector security posture differ from other products, security products? I think Sysdig was mentioned as a possibility. So, we didn't get too much into the capabilities of a solution like NeuVector. There's other resources and recorded videos for that. But at a high level, all of the network capabilities and the packet inspection, DLP, essentially your visibility and protection against network attacks, zero-day attacks, and deep packet inspection of containerized traffic. That's something that no other security solution can do. And then if you couple that with what we just showed, which is really being able to declare those rules as well as process, file, and other rules, for example, admission control rules, in a cloud native fashion, many security products are trying to deploy old methods of, kind of separately installed software or agents and not really fully cloud native. So you're not going to be able to fully automate it like we just showed. Another question, can you use OPA and /Rego? NeuVector deploys its own admission controller resources. We didn't show all of the capabilities of admission control in NeuVector, but they include things like, fail a deployment if there's too many vulnerabilities or if there's compliance violations. But all of the YAML files and CRD policies, the example that we showed, can be imported into Rego, into OPA. And Rego can be used as a query language to query the NeuVector policies as well. We do have a recorded demo that our CTO, Gary Dwan, did about 6 months ago about using OPA with NeuVector. Another question, can we have both protect mode and monitor to learn and improve? Yes, each deployment, so each application, I think we saw 3 applications in that stack, Nginx, Node, and Redis. Each one can be in a different protection mode. So one can be in a monitor mode where you're just being alerted, and another one that you've fully characterized and you really want to lock down can be in the protect mode, which would block any unauthorized activity. Another question is about being able to control the, let's see, I'm trying to look at the chat here as well. Being able to control the plugins that are loading. So how do you limit plugin loads when one module requires a plugin and another does not require a plugin? Alejandro, any ideas? Like if some plugins are not used?
About with this question, the recommendation is try to when you use or you build some Terraform module, you have the control to configure the specific providers or plugin that you are going to use in this specific module. When you join or mix modules inside of your deployment, you are able to separate to get in different folder or in different structure your modules deployment, just to keep maybe use the best practice to separate or control your module installation using the specific plugin for each module that you are installing in your deployment or your infrastructure as a code approach. Okay.
Okay, thanks. What's the difference between using Terraform versus Helm or even an operator? And then someone else asked, and even CloudFormation. You know, how do you choose what to use?
Yes, it depends the scenario, because when you use for a specific CloudFormation, maybe you need to run a couple of Kubernetes commands or get some more perform some activities or a specific commands that we can use in CloudFormation, because in Terraform we could use a specific modules with for Terraform, for Kubernetes, for Helm installation. When we use CloudFormation, this is not possible, because CloudFormation is only depend the AWS deployment resource inside the platform.
Yep.
This is the.
Yep, thank you. It says, looks like NeuVector can control what traffic is allowed via network policies. Is this a complement or replacement to security groups or network access control lists? Oh, that's a good question. So first of all, NeuVector is not controlling the network traffic via Kubernetes network policy. NeuVector is, we've actually written our own packet filtering firewall. So all of our policies are layer 7 security rules by default. So we can say, this pod can connect to this other pod using the Redis protocol. And in addition to that, deep packet inspection is used to look at the payload and to look for sensitive data within that. So we don't use or rely on network policy, Istio, eBPF, or other technologies. We've had our own, because we really need to be multi-protocol and scalable and fast. Now, there are, of course, in AWS or other public cloud providers, you can create security groups that block network connections between hosts. And if you've configured those improperly, then, of course, NeuVector may be allowing connections between pods on different hosts, but you may have security groups or firewall rules on your cloud provider that are blocking things. So those can provide some tricky debug situations. Let's see, any resource pointers or links? So this is a general blog. We'll be publishing a guide soon. In the PowerPoint, which we'll send out to all of you afterwards, there are links to HashiCorp's descriptions, as well as the examples that Alejandro used in today's demos. So all of those would be available and sent out automatically after the webinar.
And then Glenn, I think we should be okay going over, just because there's so much engagement right now. We do have another question from Raj in the chat box. I had one scenario. Did you want to go ahead and?
Yeah, that might be more of a comment. Raj is saying he had a scenario where a custom module uses a plugin and it impacted another one because the plugin directory is shared, and they're getting loaded and causing issues. So yeah, there's probably situations where plugins can conflict with each other. Hopefully over time, those would be kind of debugged if they're avoidable.
Yes, in this case, this scenario sounds like you are using a couple of modules inside the one configuration. When you apply your configuration, all the plugins are safe, or is going to cache inside your root folder, and maybe this is the approach that you're getting some errors with all the plugins. Our recommendation is try to separate the modules and get all the specific plugins for each module inside each folder.
Mm-hmm.
It's just to avoid this mix of plugins inside the same folder.
Mm-hmm.
And versions also.
Thanks, Alejandro. Maybe one more question and then we'll call it a day. Oh, somebody has a comment that Terraform is cloud agnostic.
Yes,
that's very true, and CloudFormation is really for AWS. So if you want to do something in a hybrid cloud or non-AWS, then Terraform supports all cloud resources, and you can even combine different resources. Last question then, how to use with CI/CD tools in a GitOps mindset. Does that make sense,
okay,
Alejandro?
This is a good question. A lot of companies or enterprise use this approach because they define a specific GitOps mindset using a specific branches to deploy the platform and get centralize all the configuration as infrastructure as a code. And we could configure maybe one specific pipeline using Jenkins, Azure DevOps, or Circle CI to specify the stage that we use today, just to init configuration, validate configuration, another stage to plan your configuration and get some approval from the security team or infrastructure team, something like that, and then apply the change inside your final infrastructure. Also, in this approach, we could use backend as best practice, because we need to storage our state, our current state of our platform inside the one cloud storage. And this is the idea to save all the configuration in one side, and every time that the team is going to make some change, they fetch the state from the storage and update all the platform using the Jenkins pipeline or CI/CD pipelines.
Yeah. Yeah, I mean, it's a good point that there are tools that can be used in the pipeline, but then there's a certain process and approach that, you know, everybody needs to follow. And that, you know, that workflow of checking in and checking out, testing needs to be followed and enforced for any of this to work. Otherwise, you're going to have a mess of all kinds of different versions and different configurations out there. Maybe actually the final question, would you recommend some good links to learn Terraform? Yeah, we can collect some and send them afterwards, Frederick. Alejandro, is there anything that comes to your mind? There's just the resources you used.
Well, in mind right now is just to read and practice the documentation from Terraform landing page. Also attend the webinar from Terraform because they have a good webinars showing some basic examples and introduce in a deep way with a couple of examples. Or sometimes I got some friends that use some course using an Udemy and some self-learning platform to get some Terraform, for example.
Okay. And maybe in one of those deep dive ones, they would answer this next question. how can you handle secrets in pipelines?
It depends on the cloud that you are going to use. Some people, when you use AWS, store the secrets using Secret Manager or Parameter Store. In some people that use Google Cloud use Vault configuration, and Azure also. It depends the security teams or details that you want to configure secrets in this case. But Jenkins also could storage a secret password, and you could use as environment bars.
Yep. Good. All right. Well, thanks everyone for sticking around on this really exciting topic. Thank you, Alejandro, for the demos and some insights. Yeah, we'll definitely collect some links that we could send out, and we'll send it out to everybody as follow-up. We'll also have a guide which goes into all these details that we talked about today. We'll publish that in the next month or so. All right, Young, anything else before we wrap it up?
No, I think this was great. Great job, Glenn. Great job, Alejandro.
All right. Have a good day, everyone.